Students, you're able to view my screen, right?
Yes, sir.
Yes,
Okay,
sir.
fine. Thank you. So yesterday we were discussing about encoders. Okay, so is there any confusion? Suppose I ask a question on encoder specifically, and a different question on priority encoders. Okay, so how will you change your truth table? So can someone unmute and respond? If a question is asked about encoder, okay, and another question is asked about priority encoder, so how is your truth table going to change? If you were keen on my yesterday's class, then you can answer this question.
Sir, in priority encoders, like for example, in the second row, if we have D1 and D2 active, like if they're having ones, then we need to give priority to D2 and not D1.
Exactly, that is right. So in priority encoder, I will be using don't care terms. Thank you, Sain. And in the normal encoder, okay, I will not be using these don't care terms. I'll be using 0. Fine. So that's the simplest way of differentiating between an encoder and priority encoder. So what are we suggesting here? It is being suggested that if in case the D value is higher, okay, I'm only considering that example here, D3 is high. So whatever comes here, irrespective of zeros or ones, I will never consider them. I will just take D3 into consideration. Okay, so that is the major differentiation between your encoders and priority encoders. And then we also looked into mux, okay, and how we actually have multiple inputs and one output coming through. How is this output coming through? Yes, how is this output coming through? Can Lavanya answer this? Yes, Lavanya, can you answer as to how are outputs enabled using mux? Or in simple, you can tell how does a mux work.
So I'm not so sure on how to answer this.
You can look into the truth table. Sachin R, would you like to answer? Sachin R.
Yes, sir. Yes, sir.
Yes, go on. How would you explain a mux? Or what is mux used for?
I'm not sure, sir.
What is mux used for? Yesterday we have seen, right? If you see this block diagram, you'll be able to understand. You have multiple inputs and then you have single output.
Multiple inputs to give a single output.
Exactly. So that is what we are talking of a mux. So if I have multiple inputs, Sachin, okay, and I need to just have one output. So in that case, I will be taking up a mux. This is the main importance of using a mux. Is that clear?
Yes, sir.
Yeah. Okay.
So,
Yes.
sir, I have a doubt, sir. So, in
Yes,
the priority encoder, so if we have more than 3 variables, like we have if 4 variables, and the number of zeros and one are equal, then in the valid column, what should be the this thing? It should
Valid
be on
column
or
will
it
be
should be
1.
off?
One valid will be 1.
Okay, sir.
Okay. Ultimately, what are we checking with valid? If there is at least one high value in that row. In that row, is there at least a single high value? That is what we are checking. See, the first one here, we have all zeros, right? So when there is all zeros, I do not know how to determine the output. So it's an invalid output. So you're understanding what we are trying to do here, how I'm differentiating between a valid output and an invalid output, right?
Yes, sir.
Yeah. So I should have at least one single high output. So it's only then I can determine that, okay, fine, this is a valid output. I can consider the values, right?
Okay, sir.
Okay.
So then
Fine.
what if we have all zeros and we can make one this thing?
Hmm.
What is it? So D, sir.
Hmm. Yes, go on.
So it's okay, it's okay.
No, tell me your doubt. It's fine.
No, so I got it, I got it.
You
We
got
need
it.
only
No,
one high input. Yes, sir.
exactly. Just only one, irrespective of anything else. Okay. If I see, for example, D1 here is high, and I don't care if anything else is one or zero. At least one of the entries should be high. So if it's one of the entries high, then I say yes, I have something towards my inputs. I have something towards my left hand side, right?
Okay. Yes,
Okay.
sir.
Can we proceed?
Yes, sir.
Fine. So we were looking into multiplexers, right? So we have multiple inputs here. And if in case I do not have 4 channels, right? I just have single channel and I want to make a selection between these inputs. So what I will do is I will use a multiplexer and I will see to it that, just one of the inputs here through my select lines. How will I say? Based on 0, 0, 0, 1, 1, 0, 1, 1. So based on these combinations, I will select which of my input is actually passing through and appearing at my output. Fine. So this is what we studied in the last class. And as per your equation, okay, equation is just representing your truth table. Okay, 0, 0. So S1 bar, S0 bar, I0, I0, S1 bar, S0 bar. Okay, so that is how you should be able to frame the function. Once the function is framed, it's a piece of cake for you guys to get the logical circuit implemented. Okay, uh, this is another representation with enable, and as I told you, we can go beyond 4:1 mux, right? We can make 16:1 mux as well. Okay, so today we will be actually looking into an important concept called an implementation table. Okay, this is called an implementation table, and you will have to concentrate a little, okay, because this is just like your K-map. This is a kind of MEV, like how we study 2 different types. So this is also a different type of um, technique. Okay, so let's take it one by one. A decoder can be used to implement a Boolean function by employing an external OR gate. If we have a Boolean function of n plus 1 variables, we take n of these variables and connect them to the selection lines, okay, of a multiplexer. The remaining single variable of the function is used for inputs to the multiplexer. Okay, that's what I have done here. Okay, so any function can be implemented using your multiplexers. I will show that. Okay, I will show that in our upcoming classes as to how to implement AND gate, OR gate, any logical gate and any universal gate using our multiplexer. Okay, fine. Chosen to be A or A bar or 1 or 0. By these decisions, the 4 values of the inputs, by connecting the other variables to the selection lines, one can implement any Boolean function with a multiplexer. As I told you, any function can be implemented with the help of these muxes. Okay, so let us take this example now. Consider the function, okay, ABC, which has values 1, 3, 5, and 6. Okay, so we know that it is a 3-variable ABC, right? So what is my next step? Building my truth table. So I will build my truth table 0, 0, 0, 0 to 1, 1, 1. So my truth table is built. Left hand side inputs Now my function, I need to make the values high wherever these numbers are mentioned. So 1, 3, 5, and 6. So at 1 it is high, at 3 it is high, and then at 5 it is high, and then at 6 it is high. Okay, so just for simplicity, what I will do here is I will put another column here, min term. Okay, so it becomes easy for me to understand 0, 1, 2, 3, 4, 5, 6, 7, right? So I will put min terms here, just the values. Okay, the min term values. I think now you should be able to differentiate between your min terms and maximums, right? So you will have your values towards your extreme left. This is an extra column, okay, that I am adding just for our comfort. It's not necessary that you have to put this. Okay, so we have three variables, okay, which is ABC. So consequently, I build the truth table, and the functions are also employed. So once this is done, okay, next I will have something called implementation table. So here in my implementation, before we look into this, let us see the explanation. The function can be implemented with a 4:1 mux. So I am going to implement this function. I don't know what function this is. Okay, just some high values are given. Okay, and I'm going to implement this using my 4:1 mux. Why 4:1 mux? Because I already have 3. So which means I cannot use 2:1 mux. Right? Okay, so which means I have to go with 4:1 mux. So since I have this, what is going to happen? Two variables P and C are applied to the selection line. So you can see this diagram here as to how the mux is implemented. Okay, I0, I1, I2, I3. These are our inputs. Okay, S1, S0. Okay, fine. 4:1 mux, and B and C are applied to the selection lines. So this is our general diagram. Internally, you see I have inputs from 0 to 3, and then my select lines 1 and 0, 0 and 1. So this is my internal diagram. Externally, I'm going to apply values here. Okay, fine. So let us now see B and C are applied to selection lines in that order. That is B to S1 and C to S0. The inputs of the multiplexer are 0, 1, A bar. Okay. So which means, how do I know that these are my inputs? How do I know that these are my inputs? It's only because these are the only combinations. Okay. Since B and C are going to select lines, I am left out only with A here, right? And now A can have two values. So it can have A, high A, or it can have low A, right? So that is A and A bar, or sometimes it can even have 0 and 1. Okay, so what I will do here is I will have inputs 0, 1, 2, 3. Okay, I0, I1, I2, I3, and then A bar, that is 0 and 1. Okay, A bar and A, and my inputs 0, 1, 2, 3, just like how I have here. I0, I1, I2, I3. So these values, I am writing it here. I0, I1, I2, I3. And then my inputs are A and A bar. So which means A is here, B is here, and C is here. Okay, B, C I'm using for my select lines, and A I'm using for my input. So A again can be split into 0 and 1. Okay, so 0 and 1. So what I'm going to do now here is I'm going to just write the min term 0, 1, 2, 3, 4, 5, 6, 7. Okay, so here what is going to happen is I am going to look for those values which are mentioned here. Okay, which means those values which are high. So 1, 3, 5, 6, 1, 3, 5, 6. Those are circled. And make sure that you write them one below the other, exactly one below the other. Okay, now since here none of 0 and 4 is not circled, so I will put a 0 here. Now here if both are circled, 1 and 5 under I1 both are circled, so I will give a 1. Okay, now here this is another case. Only the lower section is circled, and that section is corresponding to A. So I will bring A here. Now in the other case, the upper section is only circled, and that is corresponding to A bar. So I bring A bar. Students, any doubts here as to how we are getting this? You can respond, you can unmute and respond. Any doubts?
No, sir.
It is clear? Yeah?
Yes, sir. It's clear.
Okay, fine. So simple, what we are doing, again, just for the benefit of everyone, I'm just giving a quick review. I put my inputs here 0, 1, 2, 3, and here I give my A value. Okay, why am I choosing A? Because A is given for inputs. B and C I am using for my select lines. Okay, since I have only three parameters here, A, B, and C, right? So BC is taken for select, and A is taken here as my input. So once I take A can have two values, which is low value and high value. 0, 1, 2, 3, 4, 5, 6, 7. Wherever these are mentioned here, or wherever you have high values, those are circled. If in case none of them are circled, it is 0, or if both are circled, it is 1. In this row across, only if this is circled, then I take A bar. Only if this is circled, you have to see the row and the column both. Okay, so I take A. So these are my final inputs. Okay, 0, 1, A bar are my final inputs, which actually gets into my mux. Okay, so I hope you are understanding as to how we are getting this. So these are my final inputs. Okay, so this one I will be putting it here. Okay, so just have a look at it. Okay, students, so any doubt here? So here, this particular section is exactly coming here as my input. So this 0, okay, this 0 is actually for I0, okay, and this 1 is for I1, and A is for I2, and similarly my A bar is for I3. Okay, so I hope you have understood as to how we are getting this. Okay, right. So this is our implementation table. So using my mux, okay, I can implement anything. So here I can give you another question. Okay, instead of these values, I can give 0, 1, 2, 3. So here your circling will change, and then these values also will change. Here ultimately you will be taking two values. Here you will be taking four values, because why 4? We are using a 4:1 mux. Okay, we're using 4:1 mux. So that's how we actually have I0, I1, I2, I3. So these are my internal values. Externally, I'm applying these values here. Okay, fine. So these are your steps for implementation. Now that we have already seen as to how we implement, okay, there's no point in reading the steps. Okay, so quickly we will just go through the steps. Express the function in its sum of minterms form. That is important, minterms form. So having a column here is going to help you out. Okay, 0, 1, 2, 3, 4, 5, 6, 7. This is going to help you out. So exactly you can know, okay, 1 is here. This is corresponding to 1. Okay, I will circle this. And these values are actually your minterm values. Okay, 0, 1, 2, 3, 4, 5, 6, 7. These are your minterms. So you are encircling the minterms. Okay, whichever is high across the output. Fine. So this is your implementation table technique. Okay. So this mux is going to implement whatever function that is given here. Okay. Fine. Assume that the ordered sequence of variable chosen for minterms is ABCD, where A is the leftmost variable in the ordered sequence of n variables, and B, C, D are the remaining n-1 variables. That is fine. Connect n-1 variables to select lines. So in our case, n-1 was what? What was n minus 1 in our case? Mithun, with the example that we took, what was n minus 1 case? Mithun P.
Sir,
Yes, I'm expecting an answer.
so what is the question, sir?
Why didn't you listen the question?
Sir, some n minus 1 case. I heard
Yes.
it, sir.
So what is n minus 1 in our example here?
N minus 1.
Huh. Okay,
I
I'll
don't
give
know,
you a
sir.
clue. I'll give you a clue. Okay.
Yes, sir.
Now here you have n minus 1 variables which are connected to select lines. So in our example that we just discussed, what are these connected to? Which are connected to select lines?
Sir, I didn't see the example, sir.
Anyone else wants to answer that question?
So the input line was connected to the signal, sir.
Okay, the select lines.
And
What about the select lines?
yeah, the select lines. So n minus 1 is 3, sir. 3.
No, what is actually n minus 1 here? N minus 1, yes, of course it is 3. And here what we are doing, we are connecting B and C. Right, that was my question. Fine. So meanwhile, just go through these um, uh, go through these points. Just give me a minute. I have an announcement. Okay, so just give me a moment. We will be having our next class as well. Okay, it was informed that you have another meeting, right? So that is cancelled. So as usual, we'll be continuing with our class. Fine. So we will be connecting the remaining n minus 1 variables to select line. So what was that here? That was B and C. Okay, B and C was connected to our select lines, and A was actually connected to my input. Then last variable, which is connected to the lowest order. Fine. List the inputs of multiplexers, and under them list all the minterms in 2 rows, A and A bar. That one we have done. Circle all the minterms of the function and inspect each column separately. Yes. Okay, so each column has to be seen. And if 2 minterms in a column are not circled, apply 0. Now these points are important. Okay, wherever I have put star, okay, these are important. Applying 0. Then when we apply 1, then when we apply A, and when A bar is applied. Okay, fine. So just see another example here. Okay, I have I0, I1, I2, I3. Okay, say for example, I take C as my input. Okay, example, in the question I give you a twist, and then I say instead of taking A as input, take C as input and take AB as select lines. Okay, so in that case what you can do is, see, the question is the same, 1356, right? The question is the same. Here also we have 1356 and it is ABC. Okay, so here if I'm taking C as my input, always remember we're starting with 0 and then 1, so which means C bar and C, or A bar and A towards our left hand side. So here, as usual, okay, we will be looking at the circling. Okay, 1 3 5 1 3 5 and 6, 1 3 5 and 6. Okay, so here 1, okay, so which means C, 3 C, 5 C, 6 C bar. Okay, so how are we getting this now? Okay, uh, so here 0 1 2 3 4 5 6 7. So I naught means what? A and B are 0. Okay, so here C bar means that is also 0. So 0 0 0, so it's going to give me 0. But here, okay, when C is high, what is going to happen? It's going to be A and B are 0, right? 0 0 1. Okay, so it's going to be 1. Okay, so similarly look at the other values also here. So when C is 1, okay, and then I1, how will I get I1? I1 means 0 1. A is 0, B is 1, right? So I get 2 here and 3. Any confusion here, students, as to how we are getting these numbers? In what order we are arranging? Any confusion?
Sir, one doubt, sir.
Hmm.
Sir, in the previous question, the same table, when we had numbered, it was like horizontally it was done, like 0, 1, 2, 3, like that. So, sir, what is the difference, sir? Like, when do we do those ordering should be varied?
Normally when you take the last bit, okay, this is what happens. Okay, how it happens? Now let me annotate, then it becomes easy for you. So I'm using the mouse, so handwriting may not be that good. So here I am using A and B. Just a moment. Okay, so here A and B are going to be my values here. Okay, and I have C here. Okay, so for C it is 0 and 1. Okay, now how do I get I naught? I naught I get only if my A and B is 0. So which means this is 0 and 0. A and B values are 0. See, it is just like this. In your K map, you were taking A, B this side, okay, and C here. Now you're able to understand. Yeah,
So,
AB
sir,
is
the
taken here.
last bit will be on the left hand side, and the first two bits will be on the right hand side.
Yes, yes.
Okay, sir. Yeah,
So
got it,
this
sir.
is a twist here, a small twist. Instead of taking A towards your left hand side, I'm taking C here. Okay, so a small twist in the question. So if I say take C as your input, so this is going to be your small change in question. You understood, right?
Yes, sir.
So I naught, which means both should be 0. Then I1 means what? It is 0 1. Then I2 means what? 1 0. Then I3 means what? 1 1. So let us take one example here. Okay, so I3 means AB is 1, A is 1, B is 1, and C, let us take this row here, C across this and across this. So C is what here? High. So which means I get one more 1 here. So triple 1 means what? Is what? 7,
C.
right? Right. So this is how we get
Yes,
the
sir.
values. Students, you understood, right? So just remember AB he is this side and C is here, just like your K-map, just like your K-map. But then we are using this kind of implementation table. Any doubts here, students? Please ask if there is any doubts. I can repeat. Yes, all of you have followed. Can I proceed?
Yes, sir.
Okay, fine. Thank you. So, so as I told you, you can implement. See now, suppose I give you this function here, okay, f of ABC and summation 1356, and I tell you minimize this. So if I just say minimize this, you can either use K-map or you can use your MEV method, right? Or you can even use your implementation table. Anything which is comfortable, you can use. But if specifically I mention use implementation method, okay, implementation table method, then you have to go with this sort of method. Okay, now this one can also be, minimized using our MEV method. Okay. So that is one exercise for all of you to check, okay, if we are getting the same values. Okay, so now let's get back to this multiplexer connection. So I have C bar and C as my inputs, right? So here, what are going to be my inputs? For I0, I'm giving C, I1 C, I2 C, I3 C bar. So I0 is having C, I1, I2. I3 is having a complement of C. So what I use? I use an inverter. S1 and S0 are connected to my select lines. So question can be in any way. I can even tell use B as your input. So if you have to use B as your input, then B will come here, right? B will come here. A and C will be here. A and C will be here. Okay. So accordingly, you will have to look for your entries. Is that clear? Fine. Now, can you all take this example? F of A, B, C, D is equal to summation 0, 1, 3, 4, 8, 9, 15. Take this example and tell me what you're going to get or how you're going to implement your mux. I want you all to implement your mux. Okay. You can take A as your input. Okay, take A as your input. A and A bar will be towards your left hand side. Can you all start solving this? I will ask anyone, okay, to turn on your video and show your workout. Yes, can we start solving this? Nirbet, can we start solving? Sayan, can we start solving?
Yes, sir.
Yes, start. All of you start. And this meeting will actually end in about 3.5 minutes. Okay, and then we will connect back in some time. So I think you can take this as your workout, okay, and we will continue, okay, our class with the next session, okay, with the next class. As I told you, you wouldn't have the